Hi everyone, in this tutorial we're going to be looking at static electricity versus current electricity. So last week we spent looking at static electricity, and this week we're going to be looking at how current electricity works. And I have a little cartoon here, Garfield comic, where he's running across the carpet building up a charge, and then he runs up to John and gives him an electric shock. And of course, from last week, we should all realise that this is static electricity. So let's have a look at the differences then between static electricity and current electricity. So static electricity is when a charge builds up in one location. So we've seen that. So for example, on a balloon. Current electricity is when electrons are on the move. So they're moving around a circuit as shown in the little diagram to the right. So let's have a look then at a Venn diagram that is going to compare both static and current electricity. And we can see the differences and similarities of both of those. So if you haven't already, pause the video here and make sure you print out the Venn diagram sheet. Make sure that you fill it in as we go along. So let's have a look then. So in static electricity, we have a build-up of electrons. In current electricity, we actually have a steady flow of electrons between an object or places. In static electricity, we involve insulators. So electrons can stay in one place until they jump to an object, and that's when you get that zap. Current electricity, however, needs a conductor, and that is a substance that allows electrons to move easily through it. For static electricity, we don't need a circuit. However, for current electricity, we do need a circuit to flow. Static electricity is a result of an imbalance of protons and electrons. Current electricity just has a constant flow of electrons. In static electricity, we have a charge that builds up on the surface of an object. And usually this is a result of friction. Current electricity, however, needs to be powered by batteries or from a power plant, so from the outlets in our houses. That uses current electricity. And we have two kinds of current electricity. We have direct, which is from batteries, and alternating current, which is from the power plants, and that's the electricity that we get in our houses from our outlets. And then finally, some examples of static electricity include a balloon sticking to a wall or lightning. And examples of current electricity is electrical appliances and batteries. So what do these two types of electricity have in common then? Both involve protons and electrons, and in both of these, only the electrons move. Protons never move. So I hope this makes sense and you enjoy the rest of today's lesson.